All right, great. So I'm actually going to give a presentation. George thought he was going on after me, so I'll give the prep presentation for his. And he gave a very sort of holistic look at big data throughout history and how the government has supported it. I'm going to give you a little bit more of a detailed look at specifically what we've been doing over the last few years and how NSF has been part of that group, that NITRE group that have been working on big data, as well as looking at NSF-specific activities that we've been doing, focusing on big data and data science as one of our priorities for the entire foundation. Now, NSF is fairly unique in that we cover all forms of science except for medical science. And so we really do have to think about data science as it supports many, many different academic disciplines. And how do we have a program around data science that is interdisciplinary, that can support domain scientists as well as what George talked about, the computer scientist with statistics knowledge or the statistician with computer science knowledge. Really, the bulk of data scientists out there are domain scientists who have read out how to work with R and read about statistics and read about Hadoop and trying to do something within their own domains, leveraging all of this new technology. Structure of my program, and I'll try to run through it fast because I know it's close to lunch, is I'll talk a little bit about some of the federal interagency activities, what we call the Big Data R&D National Initiative. I'll talk to you about how NSF has made data science a priority goal for the next 2 years across the entire foundation and our strategies around data science. I'll talk about something called the Regional Big Data Innovation Hubs, which is a new sort of program that we're trying to plan for around data science and some future activities that we're moving through. So the National Big Data R&D Initiative actually came out of a request by PCAST, which is the President's Council of Advisors on Science and Technology, saying that every federal agency really needs to have some sort of big data strategy. And they quoted really two reasons for it. One of them is that big data has the potential to really transform all the areas of national priority, whether it's energy or medicine or public safety. They also recognize it as sort of a platform technology and requested that the federal government increased R&D investments. And so the National Big Data R&D Initiative really came out of this request, realizing the potential big data had for the federal government in research. George talked a lot about NITRE. So NSF is sort of one of the lead agencies of NITRE. NSF sits as one of the co-chairs of the Big Data Senior Steering Group, along with NIH. But many, many agencies are involved. DOE, NASA, DARPA, DHS are involved in the Big Data Senior Steering Group, are involved in all of these activities. So what's the role of NSF specifically? Well, NSF has a fairly important role in the field of computer science because we do fund something like, I think that the last number was 85% of academic researchers are funded by NSF in the computer science field. And therefore, we, through our core programs and through our extended programs, fund everything from the knowledge management side to the analytics side to what we call computational scientific discovery. This is sort of our domain scientists and how they use everything from high performance computing to Hadoop to all of the different platforms for management and discovery. So the initiative launched in March of 2012, and what it really launched at was a federal funding opportunity launch. So in March of 2012, we had many, many agencies announcing new solicitations and programs that different universities could apply to. When you summed up all of the new funding, it was about $200 million of funding just for big data across many, many federal agencies. One of the cornerstone announcements was a collaborative solicitation between NIH and NSF to fund what we call core technologies in data science. This is algorithms, data mining, and et cetera. I'll show you some of the outputs from that very first call of that solicitation. So as you can see, the breakdown of the actual awards made primarily in the areas of data collection management, mining, machine learning, sort of what we classically think of as big data. But also, because of NIH involvement, a quarter of the awards went to health and bioinformatics projects. A good portion went also into social network and algorithmic foundations for big data, as well as some of the domain disciplines like physical science and engineering, and some projects that focused on cyber infrastructure. We've had a second solicitation that was out, and awards made from the second solicitation as well. The second time around, because NIH had BD2K as a separate announcement, that solicitation was NSF alone. And the big difference is for that and the program moving forward is not only do we focus on the core foundational research, there's a second track that's applications. So novel applications within specific domains that require foundational changes in research in computer science, but also allow some of the funding goes towards that particular domain application. So moving forward from the 2012 timeframe, we did realize that it wasn't enough for the federal government to be thinking of, even though we are primarily federal funding agencies, to be thinking only about what the federal government can do, because big data is such a sort of all-encompassing, popular term, and the federal government really is a very small piece of that research pie. So moving into the second phase of this initiative, we really started to think about big data as an all-hands-on-deck effort. How do we encourage more people to break through their silos? Sometimes we talk about domain silos or disciplinary silos, but really also our organizational silos. How do we get federal government, industry, academia, and nonprofits to work together to solve specific societal challenges that big data can be used to really find unique solutions? And so we held another event where we, this is called the Data to Knowledge Action event, where we launched 29 new projects. Every single project was a multi-stakeholder partnership between many different organizations geared towards specific topics, and involved a large number of different kinds of organizations. I think if you sum the amount of support that was being launched, it came out to be about $100 million of new support, primarily not from the federal government, primarily from foundations, from for-profit organizations working around different big data challenges. And this happened in November of 2013. Before I wrap up on some of the historical federal activities, I think it's important to note that along with our big data R&D initiative activities, there were 2 reports that came out of the Office of Science and Technology Policy around big data and privacy. This was from PCAST, the Presidential Council of Advisors, and also from the Office of the President, really examining what the role of big data has in society. The President's report discusses risks for discrimination and various policy and legal aspects of big data and privacy, whereas the PCAST report offers some technological perspectives looking forward in the 5-year to 10-year time frame about what could the potential problems and also solutions that could be offered with research in big data for issues around information privacy. As part of the launch that happened in November 2012, NSF launched a Council for Big Data Ethics in Society. They opened up this year, and this council, headed by Dana Boyd, is meant to provide white papers and interdisciplinary thinking about big data and privacy, particularly for the perspective of our PIs, our researchers. How do you avoid, sort of IRB-like issues around big data information that isn't covered by the standard sort of IRB process, right? It's thinking a little bit more holistically. So I want to move on to the second part of my talk, which is to think about, to talk a little bit about what NSF is doing around data science over the next 2 years. So NSF recently came up with a new strategic plan, and in it highlighted 3 different priority goals for the entire foundation over the next 2 years. One of them was data science. This is fairly impactful because NSF is built like a series of disciplinary silos. You have math and physical science, you have biology. We sort of interact together, but these priority goals are overarching for every single discipline. And data science is really the only topical one that's on the priority goals. The other ones are more performance goals for NSF, so us processing your proposals faster goals. Before we define, I have my definition of data science too. Unlike George's, who he heard from somebody, this one is actually the official National Science Board definition of data science, and you can see that it's quite all-encompassing, right? It includes disciplinary experts, librarians, archivists, curators, computer scientists. So we really are looking at everybody who could consider themselves a data scientist when we're talking about the programs that we want to do to support data science. So the first part of this priority goal is something we call human capital development, which is really just how do we support the education of people who would be considered themselves data scientists or somehow influenced by data science. And this can be broken up into sort of 4 separate parts. One of them is probably the most impactful, which is that we want to look at all of our programs that involve data science in some way and augment them with either add-ons or new data tracks. We want to augment 75% of them so that they specifically deal with data science education. And this can range anything from, I mentioned this, there's an NRT, National Research Traineeship Program. This used to be called IGERT, very, very large graduate student traineeship program. This year, NRT's priority goal was data science, right? And that selected out, in particular, had an extra sort of review criteria that projects would be review higher if they were data science related. Other programs would simply add language that asked you to specify how you would train your students in data science if you were going to do something that was disciplinary but also involved intensive data science and be part of the review process. Second way that we wanted to do, as I mentioned, was NRT, right? We really are looking for ways that we can educate and support more graduate students in their careers. Graduate students specifically, but also broadly for maybe undergrads, but really graduate students is kind of a focus of this particular initiative. And I failed to mention the initiative, though it's across all of the domains, it's led by computer science and NSF's education directorate. The other thing we want to do is build a sense of the data science community. Most data scientists come from a domain discipline, right? They go to their conference on generally their domain, their disciplines. So what we are trying to do is actually build a workshop for graduate students to come together from all different disciplines to think about data science. Now, this is not just go to KDD, which is really for computer science. This is what can we do to create a cohort of students that identify themselves as data science, even as they sit as a social scientist or biologist or engineers. And hopefully, if this is popular and successful, build upon this as a workshop series, as a conference series, and build a cohort of students moving forward. Finally, we're trying to collect some data ourselves on assessing success and career paths for people who go and get data science training as a way of motivating and getting some information out there and maybe even encouraging more people to get training in data science. So far, I've listed some of the research programs that have been impacted by this. The ones that have stated some things about PhD level training or master's level training, I've listed here everything. I've mentioned the research traineeship program, but also the core program at NSF around education has had language inserted about training data scientists in it. Our HBCU UP program, which is our historically black college and universities undergraduate program, also has new language about data science inserted to it. And then for computer science are some of our major solicitations, including SATSI, this is our secure and trustworthy computing, XPS, or exploiting parallelism, scalability, and the National Robotics Initiative, all have new language for the new call that says, you need to go describe how you're training your graduate students in data science. You can't just throw them in there and expect them to learn. A second focus of the data science sort of priority goal for NSF has been this idea of how do we better support research communities? How do we take research communities that are not optimally leveraging the tools that are out there for big data, and help them sort of, move across that threshold. How do we take communities that do use some, big data, new novel big data techniques and really allow them to build their communities? And so we primarily do it through two programs right now. One of them was the new Critical Techniques and Technologies program that I mentioned. The other one is Data Infrastructure Building Blocks. So DIBS, I'll talk a little bit more about. It's a program that has two phases. One, in a phase one award, people start building a very, very preliminary prototype to build some sort of data infrastructure for a specific community. And I say community, not discipline, because discipline is too large a term, for a specific community within a discipline. After 3 years, they can apply for an early implementation award, which actually does a scale-out build for that particular community of a data infrastructure. And they've been 2 rounds of DIBS already that have been awarded, and so this is an ongoing solicitation that comes out yearly. So I'm going to move on to the third sort of key thing that's coming out of NSF's big data priority goal activities, which is the idea of big data regional innovation hubs. Now this is stems a little bit out of the effort of the second year of the National Big Data R&D Initiative, where we talked about multi-stakeholder partnerships, we talked about breaking through silos. So realizing that we need to continue this effort, not just in DC or in the sort of on a national scale, perhaps on a regional scale. How do we create a sustained series of activities where we bring people together to foster new and innovative big data projects that's using many different sort of organizations that can contribute. And so we're in the planning stages for a Big Data Regional Innovation Hub program. We've just released an RFI. The responses were due just this week. We got very successful, large volume of responses discussing how really from universities, from the private sector, from nonprofits, asking us and giving us suggestions on how we might structure the program. So the basic premise of the program is that we want the hubs to act in a role within their regions to do a few different things. Now, not every hub will do all of these things. Some hubs will focus on some things and some hubs on other things. But these are the main things that we want the hubs to do. One of them is to perhaps really accelerate ideation and development of new solutions and projects. So really bringing it from technology all the way to the end user and trying to develop a full solution at the end, engaging our private sector partners. The other thing is we really want the hubs to perhaps act as a matchmaker between the academic community and the industry community to better transition to practice, to better accelerate that process. We want some hubs to engage with opinion leaders and thought leaders, particularly around the issues of privacy and also the societal impact of big data, bringing together really, people who have opinions and, perhaps creating white papers and other levels of engagement. We'd also like the hubs to be a coordinator, especially regionally, to take all the different stakeholders in that particular region and focus their energies on collaborative activities. I talked about increasing the tech transfer between universities and large and small businesses. We also want really the hubs to think about education, like what can we do to not just better educate graduate students, but perhaps K-12, and perhaps people who may not be data scientists. What about the people who just need to use the output of data analytics in their day-to-day jobs? And so the last thing, and I just wanted to touch on, am I fine for that? Okay. So the last thing I wanted to touch upon was the next steps for the broader federal initiative around big data. And so I've shown you this timeline here. We've had a launch. We've made awards for programs at NSF and across the agencies. We had a second year where we talked about this data to action activity. Those projects have progressed, and actually you can see the listing of the projects and sort of a status update of what they've done on the NIDRD webpage, on the Big Data Senior Steering Group webpage. So right now, we're sort of in year 3 or year two plus, planning for year 4, really. What are we going to do now with the National Big Data R&D Initiative? And George mentioned this a little bit. We are trying to create a new big data strategic plan. And currently, the agencies have gotten together, and we've had a lot of internal workshops, and we've released a preliminary set of ideas, a vision, and a framework out to the public, and we've released it for public comment. And we would love to get your comments back. And if you go to this website, you can submit, your comments on the framework that we've thought up so far. And really, what we want you to comment on is the idea of game changers. What are the things that we as the federal government can support that would really break down those bottlenecks in data science, not only scientifically in the research community, but organizationally, right? What are the ways that you would love to be able to interact with industry, interact with other folks to make the most impact of your research, but you can't right now? And we're starting to do that a little bit with the big data regional hubs, because that's an activity that really usually NSF doesn't fund this type of activity where it's so holistic. But we're trying to move to something where we're trying to take the pipeline of data to knowledge to action, and realizing that we can't just fund fundamental science and not fund anything else and expect that to make a big impact. And so really the agencies are asking you for your ideas and what are the big things that we need to focus on when we think about our general broad federal strategy for research. The vision that we have, right, is really to have this innovation ecosystem, and I don't say federal innovation ecosystem or university innovation ecosystem, it's the broader national innovation ecosystem that involves many different parties, to really allow us to do the things that big data promises. And our vision statement, it's, if you want to read it, I'm not going to read through it all, involves everything from accelerating scientific progress to creating new fields of research to helping the economy to educating the workforce. And it is a very broad vision and a very sort of forward-looking vision. But what we really need is for you to help us focus that vision and focus on the areas that can help us bring about that vision. So our questions are, we think about next generation capabilities. What would be the sort of biggest topics at the frontiers of creating next generation capabilities? There's this question of trustworthiness and uncertainty that people haven't attacked very well in big data. We've done a lot of analytics, but we haven't thought about, well, how good is that research, is that output from data analytics? How repeatable is it? How reproducible is the process and the workflow pipeline of getting to that analysis? Until we get a better grasp at this idea of trustworthiness and uncertainty, that knowledge to action part always gets blocked, because you can't really take action until you really know what this knowledge is that you're seeing. A third sort of priority we're thinking about is the idea of cyber infrastructure. What is the cyber infrastructure that our research communities need? What are the things that we need to support? What are the things that can be supported from outside of the federal government? And also broadly, how do we just improve this national landscape for big data talent? Now, everybody's read this McKinsey report that says we have not enough people who are data scientists for the demand for data science. So how do we improve that? And I think there's a lot of focus on the idea of increasing diversity, right? We cannot have half of the workforce not be involved in the process of becoming data scientists when we need so many data scientists. And so as we think about these sort of topical areas, we are also asking the question of, organizationally, how do we foster new partnerships? What are the kinds of ways that universities, industry might want to interact with the federal government in creating new partnerships? How do we create new gateways between the different agencies themselves? Because as federal government actually has quite siloed itself between agencies. And also, how do we create a sort of sustainable ecosystem for big data? People like to use the phrase, how do we create for big data what we have for open source software? Open source software is incredibly sort of sustained community of people adding things in and editing software for broad open use. But data's not there yet. People are still very proprietary with their data, right? So how do we build those platforms and those collaboration networks that actually incentivize scientists, citizen scientists, and everybody out there to actually share data and make those platforms sustainable the way that open source software has been so successful over the last 5 years. So I just wanted to finish on that and get people ready for lunch. And if you guys have any questions, just ask me, and this is my email address.